So, good afternoon, one and all present here. This is our history written in the books of Tessat. This is one of the first meetings that is going to be live. I don't think that this is ever done in any companies, and it is going live in LinkedIn. So, we'll be trying other options in the future, but let's see how it turns out. Okay, so the aim of the meeting that is going to be hosted right now is we'll be constantly making suggestions and advices from the mentors and the community that we are building, and it's an exchange of information with within us, and what we are building with others too from the outside of the office. So I think the aim of the meeting is all clear right now. So this is Asif, our CTO, and myself, Edwin. I'm the CEO of the company. So right now we'll be breaking down each and everyone's responsibilities and works. So first of all, let me brief my work. So I'm currently working on the product strategy and how we are going to market our products into our websites. So the thing we learned from the past couple of 2 years is what our market need is and how we are sustaining all these years without proper marketing and all. So the thing is that we have found many prototypes, many R&D, all this way, but we have to come to a point where we have to focus on, right? So we have come to these things. One is GyanSat. GyanSat can be used for educational and research purpose. And with collaboration with 𝗙𝗿𝗶𝗆 and ISRO, we will be launching these satellites according to the customer need. So the customers that we are focusing here is research institutions and the colleges. If they want to take any research that in the further level of achievement, like different data that required from different altitude of the atmosphere, they can approach us and retrieve the GyanSat architecture from us. So for that, we have developed GyanSat 1, GyanSat. Yeah, so that is actually officially being shelved right now. We'll be developing our last model, and it was our very first product that we developed ever, and it will be one of the history marked things. But the limitation with that GyanSat was it's only 1 kilometer to 2 kilometer range. We should be targeting more. So the GyanSat version 2, that is what I am listing here, its target has been raised from 70 to 80 kilometer, from 1 kilometer to 70 kilometers. That's the scale that we are growing right now. So after 1 year, after the GyanSat 2, we'll be launching our 𝗙𝗿𝗶𝗆 mission. 𝗙𝗿𝗶 mission is actually a collaboration with the PSLV. Will be our very first orbital mission, where we testing our project on our R&D basis in an orbital level. So that's the focus on the 𝗙𝗿𝗶 mission, and we'll be having other revenue streams to sustain our company, including drones. And speaking of drones, we developed the design for 𝗲𝗏 V1, and it was actually for the Sikkim government for detecting the 𝗲𝗏 prediction systems. So the 𝗲𝗏 is actually a thing we have already mentioned. For the sake of the live, I will be mentioning again. So 𝗲𝗏 is actually happening because of the glaciers in Himalayas. So you know how glaciers work. It's actually a semi-solid water, right? It's very thick ice flowing. So after some point of time, there'll be a naturally occurring dam that will be making a large water bodies like lakes. So after a point of time, it will break because it's actually naturally occurring, right? So after the breaking of the dam, it will cause a massive natural disaster. So the government's requirement was to predict this disaster occurring. So we developed a surveillance drone for that application, but we didn't got the contract. But it has a huge possibilities in surveillance systems. But there were limitations for what we learned from the design. So right now we got the time to fully focus on the company. Like we are freshers right now. So with the help of our mechanical design head, 𝗔𝗏𝗲, right now he's absent, he'll be joining in our live. We developed 𝗲𝗏 version 2. So with that one, we approached a VTOL architecture. You know what is VTOL? Vertical takeoff. So that's what the new architecture is all about in 𝗲𝗏 V2, and we applied some more applications. And when this live is actually going on, you can check it out on our website. It will be listed, and you can apply for the expression of interest. And when the expression of interest comes to a threshold that we target, we will be launching the product. Unless and until the customer requires this product, we won't be investing our time and the capital into that project. We still have the design and everything, but it will be in a temporary stage right now. Okay, and we do have a project 𝗲𝗏 V3 where we are focusing on a multi aerial approach. The drone can be traveled through air and water at the same time. Okay, you may have seen the drones that we fly through air, right? So this drone can actually drive through water and the air at the same time. Okay, so we are developing that one also in background with the help of mechanical design engineer. Okay, so that's all about the drone wings that I spoke about. And the other product that we are targeting is flight software. And the flight software is actually for the drones and the satellite that we are developing. And the flight software has a unique advantage also. That is actually our mission also. We are trying to find alternative solutions for the satellites, right? So the core project is flight software. And right now in Tessat, we don't have a core, like full-time software team right now. So we are actually building our team. So for which we need a team for making drone and the flight software. Okay, so I am actually working on the team procurement also. So that's all the work that I'm doing. And yes, we are developing the satellite kit also. And it's basically an edutech project that we also get a free revenue stream out of all these projects. So that's all the projects that we are targeting. And right now in Tessat, I should mention that we are ongoing with the internship program, right? So you guys, we do have 16 interns on board right now, and there are many more applications coming in to help with the DHARMA and the flight software. So I should say that comparing to the last month's work progress, right now we have excelled 118% advancement with the help of you. You should clap your hands because this is an achievement that we have never achieved before. Without you guys, this trajectory won't be possible. And you just opened my eyes because you showed that how much important is the team and the number of team members helping to make the project alive. Because the project that you are focused right now helped me to focus on the other things that the company is needed. It's a necessity for the company also. So thank you guys. Thank you for your time. And let me pass the podium to Asif.
Thank you, Edwin. And hey all, I'm Asif Mohammed Sadiq, and I'm the Chief Technology Officer at Tessat. And talking about the works I do here, I'm the hardware design lead, development and research lead here. And currently with the help of the new interns here, we are developing currently 3 projects, DHARMA, satellite kit, and the last one is GyanSat. Currently the GyanSat work has been held for some time and we'll be getting back to it soon. But for now, we'll be working on satellite kit development and that will be on the market soon. And now we have like separated the functions or the different hardware parts of satellite kit to different teams in the interns itself, and they are developing that part, and almost the design schematics and the testing has been done here, and we'll be moving to the PCB formation and design soon, and that will be out soon, and the product will be soon in the market just in maximum of 6 months itself. And talking about the next project, that is DHARMA. Currently we are working on the V2 stage, and the hardware design, the outer shell 3D design has been completed with the help of hardware design lead Sri Shankar. And currently the simulations and also a simulation of different atmosphere, like the high wind orbital places and also the place where the air density is very low, also where the density is very high. The current drone simulations excel very much, and in that team I'm working on the avionics development, and the latest BOM and the latest design for the avionics has been finalized, and we'll be working on the final shell design and also the prototyping soon. And also the first prototype for the satellite kit has been also been completed. Like the 90% works has been completed, and that's all for the hardware works that we are doing right now. And just as Edwin said, I'm really grateful for all the interns here, because the most of the works and the speed of the pace of the works has been like improved very much, and we are able to focus on the hardcore development design and everything more focused and more easily because of you guys. So kudos to all of you. And yeah, so that's all the hardware news that I want to like talk to you. And next, talking about our website, we also have a 𝗙𝗶𝗶𝗆𝗆 𝗕𝗿𝗶𝗆𝗆, and she is the one who has been doing all the back-end works and all the maintenance works of our website here. And I don't know if you guys have noticed, but we are getting a lot of compliments that our website has been improved a lot from the initial stages. So kudos to Kezia too, and thanks for your help. And yeah, Kezia, please come to the podium and explain what have you done and what's your work, why not?
Thank you, Asif. Myself, Kezia. I am the administrator and the web developer currently in our Tessat Space company. And speaking of the administration part, as CEO has already mentioned, we have onboarded 16 interns and the applications are still going on. And currently we have 8 employees. And on the web development part, we had a nice website, but it didn't really convey what our website actually was. And it was very difficult for the customers to approach also. So we worked on that part, changed most of the content as it was really made in the initial stage. So we have improved a lot through the journey. So we had to change the contents. So we have made that. And also I basically worked on the about section, internships, and adding the products of, as already mentioned, Dharma. Our product. I have worked on adding that page also. Thank you.
So give a claps to Kezia because as you said, this is actually a milestone for us also because the work we do is actually transmitted to the customers or the community that we're building is via our website, right? That's the only media that is actually putting our work into the public. So she's actually doing a pretty much very job to accumulate all the works into a website. So again, and she's actually doing for the free. Okay, so let me invite every interns to just to explain your work and how is it going, an update, so that we can discuss it on and make it improve. Okay, so who will be coming first? Ashwin. So this is Akshin Sudev. He's one of the, what can I say? He's a very good chap. Okay, so.
Okay, already introduced me. I am Akshin Sudev. I am working here as a technical intern. I will introduce my team. Ashwin Girish, Srihari, and Nandana. These all are our team. I think coming here we actually start with working.
Sorry. The recording might stop, that's why. Don't touch the screen, okay?
Okay. The first project we actually done was the satellite kit. We are assigned to work in sensors layer. We build a schematic for the sensor layer completely. We build a footprint for that, and then we start to work on prototype. I think we completely test all the sensors and completely ensure that the second layer means we are actually working on the CubeSat second layer, sensors layer. We completely ensure that all sensors are working. We produce a 3D model for that also. This is the first thing we done here. Next we are assigned to do the MCU plus MBU layer. This time we done it on KiCad. Ashwin will tell about that.
So myself, Ashwin Girish, I'm also a technical intern in this team. As our team lead addressed, we were assigned to work on the second layer, which is MCU. So we used KiCad instead of ECD, which is more simple. After we studied what our requirement was and understood that we customly built a PCB board, which was pretty tough. Okay. Then we are currently at the footprint stage, but we are facing a problem, which is testing. So we need a solution from you guys. We are currently, because we customly built the PCB, so we cannot, completely trust on any testing ideas. So we need a solution from you guys. Okay.
And what about other works you're doing here?
Okay.
PCB,
we have lent a hand in the descending mechanism. We were worked on the sensor layer first, which is the third layer. Then we were helped in the BOM particles of the, the satellite kit BOM. Okay.
Like you also worked on the V2 version of GyanSat 2.
Yes.
Yeah. And the BOM part is being like.
Yes, we also worked in that. Next, design mechanism, our technical intern Nandana will explain.
Okay, I am Nandana M, and now I am going to tell about the descending mechanism we researched for our for the stabilization of the GyanSat. Our finalized concept was a two parachute mechanism plus eight petal structure. It was our finalized concept. In this concept, we uses two parachutes that deploys at two different times, which helps to maintain stability and increase the flight time. Then there are also 8 petals, 4 on the top and the other 4 on the bottom, which helps to increase the stability and accuracy of landing. Okay, then we researched more about the several stabilization concept, which includes pendulum stabilization, battery sled stabilization. Okay, then we finally all these concepts have their own limitations and their own advantages. So we finalized this concept, that is this 2 parachute and 8 petals concept. That was the field we are working. Then we worked on the BOM preparation of the GyanSat version 2. We are currently working on that BOM preparation. Okay, that's the current work we are going through. Okay, thank you.
As both of them mentioned, we actually completed MCU satellite kit sensor layer schematic, and we built a prototype for that, and then we worked on first MCU plus MPU layer. Also, we complete the schematic of that. Then we helped the descending mechanism team, and we suggested a good idea, and they developed a great idea, and they are on the simulation process. Okay, then what we do is work on GyanSat antenna. I think we done a lot of work to suggest an antenna for GyanSat. I think we are currently working on the helical antenna. We face a problem is that we doesn't able to, today is our actually the last date for the submission. We doesn't able to complete that due to it's need an omnidirectional sender. So we need some more time needed. So these are the stat we are all currently working on. Thank you.
So yeah, that was an hefty work for the interns here, because like all this development research and all is like everything is new to them, but even though they have done a hefty lots of work, and thank you guys, and I don't think like you haven't done this much of work in a long time. Yeah, thank you. And we'll be moving to the next team, so who will be leading them? Yeah, thank you.
Hi, good afternoon. I'm Manas Jeprince, and this is Adidev and Gokul. We are working as a project engineer interns. First we did was our assigned project was developing an educational CubeSat kit, and these were in that it was divided into different layers, and our work was mainly on the BMS layer, that is the power management sections, and we currently worked on the the schematic, and we did that on the ECEDA, and now we are doing it on KiCad, and we did prototyping too, whether if it's working or not, if the sensors, and we found some corrections, and quality checks were done in between, and we got necessary and then we worked on now we are currently working on the BOM of the GyanSat V2, and and along with that we are also working on the mechanical and the Fusion 360, and 𝗲𝗲𝗲 will explain about that.
Astronomer, I'm 𝗲𝗲𝗲𝗲𝗃, working as a project engineer intern. As mentioned earlier, we had pitched an idea for the GyanSat V2 with some 8 petals and 2 parachutes like that. Now I am along with working on the CubeSat, working along with the CubeSat kit like the BMS module. We had created the schematics and all. The next step is to create the footprint and the PCB design. And along with that, I am also working on creating the 3D model and simulating the idea which we had already presented to them, the one with the 8 petals and all. And I am currently working on that, on creating the 3D model using the Autodesk Fusion 360.
Okay, myself Gokul. On the first day, we splitted into 2 teams, that are project team and technical team, and these teams are divided into 4, and some of them worked on the BMS, and some others worked on the MCU and the sensors layers. Then we we made a schematic using the ECEDA, and we revised it many times until the admin approved the design, and then we jumped into on the main project, our GyanSat version 2. We introduced many descending mechanisms like used in the SpaceX projects, and we revised it many times, and we are currently working on the antenna designing, and we are currently ended up with the antenna designing software, and we are keep learning about the working of antenna and the launching vehicle. Okay, that's all.
So I think we got an idea what they are doing. So at the last we can be discussing what the problems they are facing and how we can solve it. So we got the idea what you're doing, and it's pretty much very good work. And you are working on different domains. That's what I noticed very much. Okay, so let's see how it's going to turn out. Okay, thank you. So who is the next team? Come. Okay.
Hi, myself Jeffin Jason. I am a project engineer at Tessat Space. So we initially started with identifying the requirements for our satellite kit project, and we had a couple of requirements. So we had a weight constraint, we had a size constraint. So we had to find and identify a couple of components, actually a lot of components, and we finalized on after the requirements were filled. Then we were divided into groups. We started designing on creating a bill of material, BOM, for all the components. Then we started with the schematics. So we initially were working on the MCU and the communication module section. We worked in ECEDA, but we had a bit of a redesign, and we right now are working in KiCad, which is a bit more advanced software, I believe. And right now we had at least 3 revisions for our schematics, because we are all new in the schematic section. So we had a bit of trouble starting on, because we had no idea how to start, but the team and supports, they are very, very helpful. So we updated our schematics. We are yet waiting for the final review of what we are going to proceed, but we are hoping to complete it at least by Monday, because we have already passed the date of deadline, but we are hoping to finish it as soon as possible. And we also did physical testing for some of the sensors and stuff. We actually encountered some of the issues, but were resolved easily. And that's all the bug. I'm not the exact part of the internal research part of the antenna section, but I've lent my small hand on some of the components, and I am for the antenna section. Siddharth will be talking about it.
Thank you, Jeffin.
Hi, I'm Siddharth. I'm a project engineer intern here. So currently I'm working on the antenna for GyanSat V2. So initially I started with research on the antenna and like different types of antenna, how an antenna works. And once I like dwelled into the research, like we initially decided we'll use a helical antenna, but then once we looked through the requirements for it, we realized that we need an antenna that uses omnidirectional radiation, and the helical antenna only uses directional radiation. So we need to like regroup and like think about what other alternatives to that solution is, and like choose a different type of antenna and like work more on that.
Hi, I'm Nitya Sakriya. Currently working in Tessat as a project engineer intern. Currently, I am working on the BOM of GyanSat Phase 2. So for that BOM, we need the deadline. The deadline was for today. For some issues, we need to postpone to Monday. So that's the only thing that I want.
Sure. So what are the other works that you have worked on?
So I have worked on first I have done in CubeSat, CubeSat satellite kit. Then the sensor layer, I was also doing that sensor layer, and then we came to GyanSat kit, which I was for that also I was working on the sensor kit.
I have to add one more point. We are yet to finalize on the footprint section of our schematics. So we are hoping to finish it by Monday, because already we have passed too many dates. So we are hoping to finish the footprinting and complete the entire schematic section by Monday and complete all the works. And the descending mechanism also, actually 16 interns, some of them took specific interest in researching it, but we all lent our hand in the descending mechanism, and some of the great ideas were developed by our part of the 16 interns, and with the support of our team and the team leads and mentors, we were able to get a great descending mechanism. And thank you for all that.
I forgot I had to take the mic. Okay. So who is the next team that you want to present? I think you're the last team, right? Yeah, come. Fast. Okay. So introduce yourself and your project.
Hi, I'm Marsha Anwar. I am a technical support intern. Initially, I worked on the descent mechanism techniques along with Nandana, and we finalized a technique. Then I worked on the communication system schematics, for which I used the LoRa RE02 and GPS module. I reviewed the data sheets, and I customized the symbol, and I developed the schematic. I used UART, SPI, I2C communication between the components and all, and I developed Then I am currently working on the bill of materials for GyanSat Phase 2, for which the deadline was today, but I hope to complete it by Monday.
Myself, Akshaya J. I'm working as technical support intern in Tessat. So initially, I worked on literature review. We both, me, Anna and Ejo worked on this, but they are not right here now. And on literature review, we searched certain patents and certain designs we searched which are related to GyanSat, and we focused on three major areas like actuator based servo lock mechanism, honeycomb structure, and parachute system. And from this we learned that not any patent till now has combined all these three features, and this has made GyanSat more unique. And I have worked on schematics of communication system, which consists of LoRa module and GPS module. So, and currently I am working on bill of material of GyanSat version 2, and we will be hoping to complete on Monday. Thank you.
Hi, I am Gayatri. I am working here as a technical support intern, and first I worked on research of descent mechanism with Nandana and Arsha, and we finalized the concept and submitted it, and then we worked on Then we worked on the communication layer of the GyanSat V2 with LoRa module and a GPS module, and we finalized it and submitted on Thursday. And now I am currently working on BOM of GyanSat. Today was the deadline, but due to some issues, we postponed it to submit on Monday. So excuses for Monday.
Good work, guys. Good work. And as it should be mentioned that right now we have two absentees, that is Anna Joseph and Ajo. They are also part of your team, right? Yeah. So combining all the five, you have done a good work. Okay. So Asif, so we should analyze what the work right now and how we can improve and complete it on the deadline. Right now, you know that the deadline was 2 to 3 days back, right? So what's the problem that you have faced because you haven't completed your work in the deadline, but the work is still going on? But what is the problem? Is it the pace, or is it confusing the software, or what should we do? Okay, so starting from each team, you know what's the problem faced by each team, right? So anyone can raise what's the problem. I think from Ashwin's team, there's a problem mentioned in the presentation itself. So anyone from the team, can you mention that problem again? Ashwin's team? Yeah, Ashwin.
Okay, as he mentioned, we are currently working on MCU plus MBU layer. Okay. We are using ESP32 and MPU 6050. Okay, due to we are actually start with ESP C3 to C3 Super Mini. It does not available on KeyCAD, so we take ESP32 Mini. What the problem is actually we faced is we doesn't get the correct pin diagram, so we customly study the each pin and build what the resistor or capacitor each pin need. So we customly build that. So we, as you early mentioned, it's cost about for printing, I think it's 50,000 or something. So it's a very high risk. So we need to test before that printing is this PCB design is correct or not though. So we need a solution for that.
Is that the only problem that you're facing?
One more. I think we are. I'm at a time also working for GyanSat antenna. We need more time. Actually, we studied a lot of antenna models available. None of them are not able to.
So once again, so in the antenna completion, like the deadline you're asking, what task will be completed? What will be the output of that deadline? What work of the antenna will be completed by that day? Like, is it the designing that you are completing on the day, or the simulation? What you are going to complete on the deadline? You want to discuss?
We are working together.
Okay, yeah.
Actually, we need more time because we don't have much information about the antennas, and we have zero knowledge about the working of the antenna. So we have to study and gather more information about the working and the types of antenna, and then we have to design the antenna, and is it compatible to the launching rocket, and there are so many constraints we have to follow, and that's the main issue.
The question that I'm asking, like you asked for the deadline, right? Like extension of the deadline. So what work will be completed by that day? What work will be? What is the output that you are targeting? Is it the simulation? Is it the design? What you're targeting? Or is it the method?
Actually, the simulation and the antenna selection are going together, completing. Okay.
So I think by next Wednesday, that is coming Wednesday, you can come. I wish that you complete the design, selection of the antenna, and try to do the simulation. Try to do. So by Monday, Srishankar will be back to the office, so you can seek the help from him. So after that, you will be making easier for your job. So I think you can complete that part. So the first problem that you discussed was the PCB. So speaking about which, we should mention that the why we selected the multi-layer PCBs. So normally in any kit that we are available in the market, you'll be getting the components that is readily available from the market, and you'll be using it to just merge it and make the project. So the thing is that we are focusing on Tessat is how to make every product innovative that we are producing. So you may ask that why we are not focusing on a CubeSat. Normally every startup first builds a CubeSat, then builds other products. So CubeSat is actually a kind of open source project. Anyone can do it. That's not Tessat. We should do what it should be done. Like if you are making a product, we should make it more novel. So speaking of the kit that we are producing for the kids, it should be more easy to use, new experience for them. So we are customly building every sensors and making it more a stackable format, like a real world satellite looks like. So that's the hardest part that we're facing, right? So the mentioned the MCU. So to testing out the MCU, I discussed with the CTO. The thing is that we can only test it out by making a PCB. Okay, so for which I saw some sources that saying fabricating a PCB costs 1,500, but I got lost the source. I have to search it once more. So I think if that's possible, it will be convenient for us to test it out. Okay, so no worries about that. We'll be finding solutions to test it out. I think there's no any solution like in the software way to test the schematics, right?
In the EDA software itself, there are possibilities for simulations, and also you can check the ESs and all, but I don't think there is a proper way to check whether the data connection is been like proper or not. Like you have to channel data through the system, right? So I don't think that is supported in the EDA systems like KiCad or anything like that. You can only check the electrical signals that has been passing or not. So just for a verification, we can test from the basics of electrical signals that has been passing, and after that, once that has been verified, I think like it will show some resources that can help with us. If that is not possible, we'll be moving to we'll be designing a proper PCB, then we'll be testing on that. And then we'll be moving to the next system and all. So that's one way we could solve or address your problem. And is there anything else, Ashwin? Nothing. Then to the next team of is there any problem that you are addressing or that we have to?
We also have the same problem with checking and all. We had got the circuits from the some sources, and we had just recreated the circuit, and we too has some problems like that. Well, the connection will be right or not. That's really the problem we have.
That's. I think you are also working on the BMS system, right? Yeah, and the power system and all that all has been completed. Yes. Okay, fine. Next, I think that is all problem of 𝗙𝗿𝗄's team only. And next, Jeffin.
So we've been working on the sensor layer. It is not a very difficult layer, because we only have two components and it's not a very difficult task to do, but we've been stuck with the schematic section for almost 3 or 4 days. We have to move on because footprint, we haven't even started footprinting, because compared to the BMS structure or the MCU integration, the communication module, our schematics are very simple. We don't have much pins to work around, but even after that we still had an issue with our temperature sensor. And because early in the morning I cleared it, asked if why you don't need a capacitor to work it, and we had that capacitor for all those 3 days. So hopefully we can start the footprinting very soon. At least even if it's possible from today onwards, we can start footprinting and probably complete it by Monday.
One thing I forgot. There's one person sitting here. She is completely zoned out. What happened, man?
Nothing.
Come. So she's our latest joining. She's our software intern. Take out the mic and speak about yourself.
Thank you for the introduction. So my name is 𝗙𝗿𝗄𝗧. So I'm a software intern at Tessat. So currently, as the project interns and the technical interns, I speak about SATKit. So I'm currently working on the software side of SATKit. So according to the requirements I have received, now I'm currently creating the lightweight desktop software where the students are able to do the hardware kit with the help of the software. So we are planning to do with an integrated IED I hope you know what is an IED. For your information, Visual Studio is an example of IED. So it is an environment where we are going to write the code for the hardware kits. So we are planning to integrate it with the software. With the software where there would be like quizzes, notes for references for doing the hardware kit. So currently I'm in the research phase. So what all should be integrated, and after that I need to speak to my lead for the confirmation. And yeah, currently doing it. So I need the help. I need help from all of you for the hardware side, to know about the hardware side or about the open source or license and all. Yeah, so thank you.
As Vaishnavi mentioned, she is working on the satellite kit project itself. That's basically all of you are doing in every team, actually included in that one. So you are doing the hardware part, she's doing the software part. It should work hand in hand, right? So the things that she's expecting from you guys is, you want to suggest the libraries that should be implemented for each sensors. And for each library, you should check that is the copyright rights also. Is it open source? Is it available for the education purpose or commercial purpose? You should check that on also. Okay, so the technology that you're seeking from anywhere from the source of internet, you should check that one. Even the schematics, the right to use is actually the very important thing. Okay, if it is not available for open source or a educational purpose, we should buy the license from them. So that should be kept in mind. It's very serious. Okay, I spotted one of the two things that you are leaving that part, that very important part in the dustbin, but it also should be considered. Okay, it's okay for learning the concept, but if you are implementing on the product, you should learn that part also, the agreement of the license. Okay, so yeah, you may continue. So I think she has plenty of time. She's just started this week, right? Yes. So I think by next weekend we will be getting the first prototype. It's okay, right? Okay. So the software will be ready by next week, Friday. Okay. And about you guys, try to complete every work that you're doing by Wednesday. Target for Monday, you will be completing on Wednesday. Okay. And whatever you're doing, do it completely perfect, with proper documentation and no errors. Okay, there should not be any loopholes left alone. Okay, everything should be attended, each and everything. Okay, it's not about the amount of work that you're doing, the perfection that you're doing. Everything should be perfect. There should not be a case where a person comes into a role that you have been already worked and should do the same work that you're done before. There should not be any rework that needed to be done for every work that you're done. Okay, so that will be a waste of time that you're implemented on the Tessat. Okay, so what you have to do is make your work perfect. You guys have only 1 week left, so use the time to make the work perfect. All right, are you guys with me? Yes. So let's get this work done by next Wednesday. Okay, everything. And coming Friday, you will be having your presentation, individual presentation, and will be closing your internship program. After that, if you want to complete your project to the complete product stage and making into the market, if you want to see that your work coming into a life, you can work in on Tessat, okay, as an intern itself, and let's see how it turns out. But it's your choice. You signed up for 1 month. After 1 month, it's your choice. Okay, no pressure. Okay, is there anything to add?
Nothing much actually, but I'm seeing a pattern here. Like, you are having problems with the deadlines itself. So first of all, I think we are pretty much like have like fast pace here. So we want this amount of work to be complete in this set of time, and some of that particular deadlines is not like feasible. I know that. But like being a startup, we have like a lot of competition. We had to be in the market first, so that's a problem here. And also, other problem is like most of you guys are like new to this domain. Like most of you are like new to using EDA tools, and most of you are like new to research. And also, I know like the adaptability is a bit hard, but getting over it, you'll get used to it. And within Wednesday, we are hoping to complete the works that is assigned to you. And if there is any problem, feel free to approach any of us. It's not a problem. And if there is another problems that you're stuck on, please feel free to share to us. And that's all about what I want to say.
One more point.
Yeah.
The pattern that I've seen in your work is you are just showing your work at the end of the day, like after the presentation. On the presentation day that you're showing all the works, then there will be feedback. That will be brutal because on that presentation is happening on the deadline, and seeing that the work is actually waste of time of yours makes us irritated. So what you have to do is make us updated each and every progress that you're doing. So we'll be keeping on track that you're on the right path or not. We are aware that you are interns, you are new to this field. We are here to assist you, okay, in your work. So in Tessat, as I mentioned before, interns are not actually learning like it's a classroom. If you want to learn, you can stay in your college days itself. If you're coming into a company, you should work as a company employee. Okay, and you are exposed to that environment right now. Right? Right, yeah? Okay, so you should adapt to this environment, and work should be completed. And on the progress, just update us. Check it out, are you doing right or not? So that you can eliminate the part where you're getting fired or getting questioned at the end of the presentation, because we are also part of the journey. Okay, so the aim is to make your time valuable. The amount of work that you're doing should be implemented perfectly, right? So we are also working on the other side of the company, but we are actually developing the products that we are designed. The aim that crafted for the company is by us, but you are making the idea into alive. So huge respect. The amount of work that you're doing, the amount of, what can I say, the affection, the sincerity that you're putting into the work is actually acknowledged right now. So thank you so much. I think everything is brief right now. Yeah. So looking forward a very productive and updated week next month. So hopefully by the next month we will be producing our first project as an MVP, and people can join through our website as an expression of interest. And people can also show interest in producing the tender also for producing some of the PCBs and the parts that we are implementing on the projects. So for any inquiry related to these projects that we have mentioned here, you can approach us by LinkedIn or a mail that will be info@tessat.space. So see you all there, and thank you guys. Thank you for joining, and we'll be looking for a good weekend. Okay. Yeah. Thank you.